Hello and welcome to another video from Israel, from Easy Academy. Now today we're going to be talking about event stream processing. Now this is a recent concept that has been trending, but it is actually something that has been around for quite a very long time. It is just that there are recent updates in technologies and frameworks that are available to make this much easier to do. So today we're going to be talking about event stream processing. You may also see me refer to it as ESP. So they all mean the same thing. So ESP and event stream processing pretty much mean the same thing. So let's get started with what I have for you today. Now we have some overview. We're going to do a brief introduction to what this particular concept is about. We're going to talk about some real world use cases. Then we're going to talk about some environments where you can implement stream processing. And then we're going to take a look at some of the strategies for doing it in the cloud, some open source technologies that are available for you to do stream processing. And then we're going to talk about some of the platform services that are available for the cloud. So what is event stream processing? So basically this has to do with the ability for you to capture data efficiently and then find a mechanism to store it, then process it. Once you process it, the next thing is you can decide to route it to another destination. But what you have to pay attention to is that the processing can be done in real time or it can be done in retrospect, meaning that you are doing it a little bit after the event has arrived. But if you want to do it near real time, it means that you have to take action on the particular event or data as soon as it arrives, your data source. Now, once the data is processed, the next thing you will have to do is to go ahead and route it to a particular destination. So let's take a look at each of these concepts one at a time. So the first one has to do with capturing data in real time. So this means that you go ahead, as soon as the data is generated at the source, you capture it. And then once you capture it, the next thing is you can go ahead and store it. Now you have to store this data in a mechanism that is efficient for you to retrieve. And also you have to be able to store it in a way that is durable. Durable means that once data is stored, you don't lose it. So some of the sources of the event and data that we're capturing could be a database, it could be a sensor, it could be an application, it could also be a user that is generating this particular activity. Once the data is stored, the next mechanism is for us to retrieve it so that we can now process the data set or the event. This typically involves filtering, which means you may use a particular criteria and then drop some of the events. You may also enrich, meaning that you may add additional fields. So let's say we were just receiving a particular customer ID or user ID. We may now use that as a foreign key to bring in other fields to enrich that data set by doing joins and some type of enrichment like that, or lookup. And then another processing mechanism would be to manipulate this data set. So manipulation has to do with sometimes converting it from one format to another format, depending on how you want to use it. Then once the data has been processed, the next step is for us to route it to a specific destination. And once it arrives at the destination could be a data store like MySQL, it could be another application, it could be another framework, maybe something like Flink or even Kafka. So basically, to summarize, we capture the data from the different data sources. We make sure that we store it in a way that is efficient. And once you store it in a way that is efficient and durable, then you can retrieve it, perform the processing, and then go ahead and route it to the specific destination. Now, like I said, the destination could be a data store or another platform technology or an application. And sometimes you can even put it back into the original data source, just in a different entity or table. Now, some of the use cases for event stream processing are things like IoT. Sometimes we have different sensors and devices that are generating events and generating data sets. We now have event stream processing being used in transportation services like Uber and Lyft, where the driver is constantly scanning for where the passengers are located, and also sometimes the passenger can also be scanning for where the drivers are located, and they can be connected in real time. So this is not something that is done after the fact. This is something that is done while the user needs to use it, and the data is being manipulated as it arrives. You may also see this being used in retail, where in the past we used to have magazines and promos and all these things being shipped and mailed to people's homes. But nowadays, you may go to a website or go to an app and browse something, and then when you're actually in the store, the application will figure out that this particular customer was interested in this particular item a little while ago in the recent past, and then it will send you the offers in real time while you are still in the store. So these are just some of the use cases where stream processing is being used to enhance the customer experience and also give the businesses a competitive advantage. So some of the environments for doing stream processing could be in on-premise environment. So this is typically when you're running this outside of the cloud. So this could be in your own data center, or sometimes like in healthcare, it is being run at the facility and not in the cloud environment. Now, if you're renting or you are subscribing to a particular service or infrastructure that you don't really own, then you could use a cloud service like Azure, like Amazon or GCP. So this is when you choose to go cloud native. So the main difference is that in on-premise, the customer or the user is responsible 100% for the infrastructure, whereas in cloud native environment, the cloud provider provides the infrastructure for you to do it. There are also situations where you, because of legal restrictions or a particular use case, the company or the team might decide to implement the project in a way where some of the resources are located in on-premise and some of it are located in the cloud, and this is when you will call it hybrid scenario. There may also be situations where you're 100% in the cloud, but across multiple cloud providers and not just one cloud. So that would be a multi-cloud scenario. There are also scenarios where all of the above applies, where the customer is in on-premise, they're also in the cloud and in multiple cloud environments. So that would be when you have all the scenarios applicable. So what are some of the strategies for doing event stream processing? The first one is called infrastructure as a service. So in infrastructure as a service, you typically have to be responsible for provisioning the servers, setting everything up, and you own and you have full control. And you also have the responsibility of taking care of everything. Whereas in platform as a service, you are only responsible for using the service, but you don't have to be responsible for maintaining everything. So you can think about these two scenarios as having your own home in the first scenario, where you are in full control, and then the second one will be like a hotel or a vacation rental, where you just pay for the service and you just use it, and when you are done, it's pretty much over. The two major differences between PaaS and IaaS is that in IaaS, infrastructure as a service, you are in full control, and you also have the responsibility of maintaining this infrastructure. Whereas in platform as a service, you are only using it, so you don't really have as much control, and also you don't really have as much responsibility. So in the cloud, you will typically choose to go with platform as a service. And then there's also software as a service, where you're just using the application and you don't really have to worry about the underlying infrastructure. So this is different from PaaS in that in PaaS, you are in control of some of the infrastructure, but not everything. Whereas with software as a service, you just use it and you're done. So if you wanted to compare these three scenarios, let's say we have a vehicle that you want to use for transportation. The first one will be you owning your own car, so that if you want to drive your car, you just get in and you drive the car. The second one would be you renting a car from a car rental service. You can drive the car as much as you want, but you don't really own the car and you just using it for a small time period. And then the final scenario would be you taking Uber or Lyft, where you just use it and then you get out of it when you are done with the usage. So that typically summarizes the three types of architectures that are possible in the cloud environment. And then what are some of the open source technologies that are available for doing stream processing? So the first one is Apache Kafka. And then we also have another one called Apache Pulsar. We have Apache Flink, we have Apache Beam, and we have Apache Spark. Now, the main differences between these technologies is that with Apache Kafka and with Apache Pulsar, you can store the events in Apache Kafka and Pulsar, and you can also use them for processing. Whereas Apache Flink, Beam, and Spark, those are primarily used for the processing part of the streams, and they're not really designed for you to do any kind of storage in the framework. So Kafka and Pulsar provides a mechanism for you to store and also process the events in real time, whereas Flink, Beam, and Spark are mainly designed for you to use them to process. Now, Flink and Beam can support the processing of real-time streaming, and then they can also support batch processing. So the main difference between batch and real-time is that with batch, you process all the events that have arrived at the same time, whereas with real time you handle it as soon as it arrives. So pretty much you don't wait to get a particular amount of events before you start to process them. You just process them as they arrive one at a time, or even in bulk. But the key difference is that with batch you have a fixed number of events you're handling, whereas with stream processing everything is happening as soon as it arrives. Now, Spark is primarily used for batch processing, although it is starting to have some real-time stream processing capabilities, but it's not really a major player yet because there are certain features that are available in Flink and Beam and Kafka, and as well as Pulsar, that is not yet available in Spark. So that is just a summary. If you would like to get a video of all these different examples, please feel free to put a description and put a comment in the below, and then I would go ahead and create a video about that particular section. So what are some of the cloud platform services that are available for stream processing? Now I'm going to focus on a particular cloud provider that I'm very familiar with, which is Microsoft Azure. So on Microsoft Azure, we have Azure Event Hubs, which provides the storage layer for you to store the events as they're coming in real time. And then we also have HD Insight, which provides some of the services for Kafka and for Spark and for Hive, Apache Hive, which can be used for both storing and querying or processing the events. And then we also have Azure Functions. Azure Functions is typically used for the processing of the events. And then we have Azure Stream Analytics, which is used to provide a SQL-like interface for you to perform the manipulation of the event as it comes in real time. And then we also have Azure Event Grid. The purpose of Azure Event Grid is for us to use it to route events from the source of the event to the handler of the event. So in this case, Event Hubs could be the source of the event, and then Azure Function could be what is handling the event. So you would use Event Grid to connect the source of the event to the handler of the event, so that as it comes in, it is being routed from the event source to event handler so that it can be processed. And then to summarize, basically what we have discussed so far is we discussed what event stream processing is, which is the ability for you to capture the event, for you to store the event in a way that is efficient and durable, and then you go ahead and retrieve the event, and then you can perform transformation, which could be either filtering, it could be manipulation, and it could be enrichment of the particular event. And then we also covered some real world use cases of event stream processing in the IoT, in the retail and transportation industries. And then we took a look at some of the environments where ESP can be implemented, whether it could be in the on-premise environment, in the cloud native environment, or a hybrid of those, or even all of the above scenarios. And then we also covered some of the cloud-based strategies for doing stream processing, as well as open source technologies and cloud-based services that are available for you to do event stream processing. So if you like this video, please go ahead and like it. You can also subscribe to the channel so that in the future, if I put similar content, you can go ahead and get the notification and find out when it comes. So thank you very much for your time today. I really appreciate you watching it all the way through to the end. So if you would like to see similar videos like this, please let me know in the comments, and share this video with someone else if you found it useful for this particular topic of event stream processing. So thank you very much, and I will see you in the next video.